classic implicit differentiation problem. Ready, Ms. Stewart?
I'm ready.
All right, here we go. So remember, again, I'm just taking the derivative of each term. The derivative of x, of course, is 1. This is already a toughie, I can see. This is going to be something with an x times something with a y. So I'm going to use the product rule on this. And I always consider the negative to be with the first term. It just comes out easier that way. So it's really the derivative of the first guy. I'm using the product rule. The derivative of the first guy, so that is negative 9x squared, times the second guy, as it is, which is y, plus the first guy. Look at the first guy. The first guy is a negative, so plus the first guy, really it's minus 3x cubed, times the derivative of the second guy. Well, the derivative of y is just 1. I don't have to write that. But I'm taking the derivative of the y term, and so you remember you have to add the dy dx. So far, so good, Ms. Stewart?
So far, so good.
Okay. Equals, on the other side, the derivative of y, again, is 1, dy dx. And the derivative of 1 is 0. So now all these problems are the same. I just look for my dy dx terms. Here they are. I move them all to one side. This time I think I'm going to move them to this side, because everybody else is already on the other side. So I have 1 minus 9x squared y. Move this guy over. So here's my dy dx. Plus 3x cubed dy dx. Right? Everybody with dy dx to one side. And I just factor it out. 1 minus 9x squared y equals, factor out dy dx from this guy. Common mistake. What should I put here?
A 1.
Thank you, Ms. Stewart. Plus 3x cubed. I factored out the dy dx. And then finally, I just divide both sides by this whole routine here, this whole guy. 1 plus 3x cubed. And should I rewrite the final answer? You got me over here, Mr.
I've gotcha.
dy dx equals, what do I have on top there? 1 minus 9x squared y. And on the bottom I have 1 plus 3x cubed. And that is it. That is my final answer. Now, you might be tempted, of course, to get rid of a couple of x's, or to get, you can't do that, though. Of course you can't, because I'm adding or subtracting one from them. And that's it.
We were talking, I saw you nodding out. London calling, see, we ain't got no hide.
Here's another problem. Let's take the derivative, shall we? And of course, since y is not easily solved for, let's use implicit differentiation to take the derivative. All right, as Mr. Haas was just saying, you just take the derivative of each piece, and you have to use whatever rule you have to use. Chain rule, power rule, product rule, quotient rule. I'm thinking the chain rule is what I need for this first piece. So let's take the derivative. Chain rule, derivative of the outside. Right, I brought the 4 down, times the inside raised to the third, times the derivative of the inside. Okay, so now power rule, 2 times 3 is 6y. Chain rule times the derivative of y, dy dx. Remember, whenever you take the derivative of something with a y in there, you have to remember the dy dx. Plus the derivative of 5, that's 0, you always like that. Okay, equals the derivative of this piece, power rule, 10x to the 4th times the derivative of x, which is 1, plus, let's see, derivative of 3 is 0. So I have taken the derivative. I'm done taking the derivative, but we like having something saying the derivative equals blah. So I have to solve for dy dx. All right, this is a little funny. I look here, and really I just have one big term over here. One term, which means I'm going to have to do a whole bunch of dividing to get this dy dx by itself. I like thinking about peeling away the layers. So let's see, let's peel away this piece first, shall we? Can I just divide by that 4 and that 3y squared plus 5 to the
good.
third. I think that's probably what you might want to start by doing. All right, so that whole piece is gone. It's looking a little better already. Just going to rewrite this. Now, all I have to get rid of is that 6y. Now, you might be tempted to say, let's divide both sides by 6y, and you absolutely could do that, but then I'm going to end up with a messy, complex fraction. I don't like that very much. I think you like it even less. So let's go back to our old Algebra 1 skills. Same thing, dividing by 6y. Same thing is to multiply by its reciprocal, 1 over 6y. The reason I do that now is now I see, oh, that just scoots right in the denominator. So I can just scooch that right into the denominator. So my numerator is unchanged. Let's see, 6. I'm just going to go ahead and multiply that by that 4. What do you think, Mr. Haas?
I think that looks good.
And just for fun, I'm going to put the y right up there. And there we go. So now I have dy dx isolated. Now you always want to ask yourself if you can simplify that, and I think I can. I've got a 10 in the numerator, a 24. Let's see, 2 goes into both of those. I think that's probably the biggest thing that I can divide out. So let's just divide out a 2 from the numerator, which leaves me with 5x to the 4th. Divide out a 2 from the denominator, 12y, 3y squared plus 5 to the third. And there, my friends, is my derivative.
I live by the river.
I'm really enjoying these. You know, this math stuff is pretty good.
It is
I
fun,
love how
right?
they all work out,
I
and how it
know.
kind of brings back all the other rules as we do this. You know, all the other shortcuts, product, quotient, chain, all that kind of stuff. It's all in there.
It
It's
is.
in there. All right. Here's another one. So again, I'll just take the derivative of each piece and go happily along. The derivative of x, done that many times. 1. I could write, of course, dx, but it's 1. I don't bother to write it. The derivative of y squared, 2y. Oh, now I'm taking the derivative of a y term, so I have to write dy dx. And of course, dy dx, just, I know we've said it a million times, but that just means the derivative of y with respect to x. It's a slope. I could have written y prime if I wanted to, but this just stands out a little bit better, I think. Uh-oh. Now I have to take the derivative of this guy. It's a quotient. I need the quotient rule. Derivative of the top, 2 times the bottom, 3x minus 1, minus the top. I know you do it in a slightly different order, Ms. Stewart. It doesn't matter. It's the same thing. That's the top. The derivative of the bottom is just 3 over the bottom squared. All right, now I've taken the derivative. Now all I have to do is simplify a little bit. So let's see if I can simplify this guy first on top. Let me just rewrite this. 1 plus 2y, dy dx equals, and I think I can just do a little distributing there. So I have 6x minus 2. This is really a minus 2x times 3, so that's minus 6x. Wow, this is going to be nice.
Yes, it is.
Over 3x minus 1 squared. So I have a 6x and a minus 6x.
Isn't that fun?
I love doing that.
I do
It's a
too.
good time. So let's see. Let me just I don't think I'll do it over here. No, wait a minute. I have this one. Well, what am I going to do with that? I think I could just subtract that. So I have, let me just keep track of what I have. I have 2y dy dx. I have this negative 2 on top. And on the bottom, I have this 3x minus 1 squared. And if I subtract this 1, that's minus 1. Oh, this one is going to be a little tricky.
It is.
So now I've got this 2y. Now to get dy dx by itself, I have to divide by this. But you know what? Maybe I'm gonna get a common denominator here so I can actually, you know what I'm saying?
I know what you're saying. That's
So-
what I was thinking too.
Yeah, I'm thinking we're thinking the same thing.
We are.
So this is -1, but really, if I put it over the same denominator, let me rewrite what I have. You still got me over here, Mr.
I have ya.
dy dx equals -2 over 3x minus 1 squared. This -1 is really minus 3x minus 1 squared over 3x minus 1 squared. Isn't that really just 1?
Yes, it is.
Okay, so now I'm almost there, hang in there, dy dx. I have a -2 and then minus, now that I have common denominators, 3x minus 1 squared over 3x minus 1 squared. It's all right?
Beautiful.
Last thing, and I think you did this in the last problem, Ms. Stewart, how do I get rid of this 2y? Well, I'm just going to multiply by the reciprocal. 1 over 2y, 1 over 2y. I'm really just about done. I'm just going to write my final answer. dy dx equals -2 minus 3x minus 1 squared. And on the bottom, I have a 2y times this. I'm just going to write my 2y first. I don't know why. 3x squared. And I am done. Now, you might be tempted to get rid of the 3x minus 1 squared. But can you do
looks
it?
so tempting.
Man, I really want to do that.
I do too.
But
And
you
the
can't.
2.
Ooh, you can't do it.
You can't do it, can you?
You can't do it because
Yeah.
this is not just one term. I have this 2, this -2.
That's right. So you're done.
There.
You've
I'm
gone
done.
about as far as you can go.
That is it.
I live by the river.
Let's try another one. A radical. All right, we're going to take the derivative of this, again using implicit differentiation, since my y is embedded in there. I'm just going to rewrite this first. Is that all right, Mr. Haas?
Yeah, I would do the same
I was
thing.
like rewriting things when I have a radical. This side is fine. Now I am ready to take the derivative. Chain rule. Okay, derivative of the outside. So that's going to be a -3/4 times the derivative of the inside. Oh my gosh, this is like a triple chain rule times the derivative of y. dy dx. Everybody with me? Derivative of the outside times the derivative of the inside, but I'm taking the derivative of y, so dy dx. That was kind of fun. Equals, okay, this one's nice power rule, 18x minus 5. Just took the derivative of each piece. So this shouldn't be too hard, because I just have one dy dx. I just have to get it by itself. But I'm not liking that negative exponent. I think before I do any multiplying or dividing, I'm just going to rewrite that. I find that easiest. So let's see. The 1 is upstairs, the 4 is downstairs. This guy is downstairs, so I'm moving 3y plus 5 into the denominator, so that becomes a +3/4. This 3 is in the numerator. And then times dy dx. Okay, I'm feeling better about this. Now, to get dy dx by itself, I just need to get rid of this. Again, I could divide both sides by that, but how messy is that?
That would be
We don't like
messy.
dividing
Yeah,
by
that's messy.
fractions. So let's just multiply by the reciprocal. I'm multiplying both sides of the equation by the reciprocal. Keep track of what I'm doing here. Okay, so this gives me a 1 dy dx, which is exactly what I wanted. And here, let's just keep track of what's upstairs in the numerator, what's downstairs in the denominator. Looks like 3 is downstairs. You know, you have to think of that whole thing being multiplied, right? So I've got the 4 times 18x minus 5 times 3y plus 5 to the 3/4. Now if I wanted wanted to, I could distribute that 4, but there's no reason to, really. In this context, we would consider that simplified. I don't think there's anything I can divide, so I'm done.
I think you're done.
There's my derivative.
Looks great.
Thank you.
The ice age is coming, the sun's zooming in.